Hi, my name is Reem Jarrar, and I will be presenting this project which demonstrates the state design pattern using a package delivery tracker. The idea is that an order behaves differently depending on its current state, such as created, paid, shipped, delivered, or cancelled. The goal of this project is to create a simple demo application that clearly shows the state pattern. I used Python and built a package delivery system where each order status controls what actions are allowed. The state pattern is used when an object has different behavior depending on its current state. Instead of putting all conditions inside one class, each state is represented by its own class. Without this pattern, the order class would need many condition checks. Every method such as pay, ship, deliver, and cancel would need to check the current state manually. This makes the code harder to read and maintain. My demo is a package delivery tracker. The user can pay for an order, ship it, deliver it, or cancel it. The result of each action depends on the current state of the package. This table shows the valid transitions. For example, an order starts in created, after payment it moves to paid, after shipping it moves to shipped, after delivery it moves to delivered. The order can also be cancelled before it is shipped. The state pattern has a context class which stores the current state, a state interface that defines common actions, concrete states that implement state-specific behavior. The client talks to the context, and the context delegates behavior to the current state object. In my project, package order is the context because it stores the current state. Order state is the abstract state interface. The concrete states are created, paid, shipped, delivered, and cancelled. The client is main, which runs the demo. In these code snippets, order state is the abstract state interface. Every concrete state must implement these same actions, but each state can respond differently. Package order is the context class. It does not decide the behavior by itself. Instead, it delegates the work to the current state object. This is why the same method, call, can behave differently depending on the current state. This is one of the concrete states. In created state, paying is allowed and moves the order to paid state. Shipping is rejected because the order has not been paid yet. Canceling is allowed and moves the order to cancelled state. This diagram shows the structure of the application, where package order has a reference to order state. Each concrete state inherits from order state and provides its own version of the actions. The demo starts by creating a package order. First, I try to ship it before payment, which is rejected. Then I pay for it, ship it, and deliver it. I also show invalid actions, like trying to cancel after the order has already shipped or delivered. This sample output shows that the same object changes behavior as its state changes. The order rejects chipping in the created state, but accepts chipping in the paid state. This is the main idea of the state pattern. The main advantage is that the code becomes cleaner because each state handles its own behavior. It is also easier to add new states later. The downside is that the design creates more classes, so it may be too much for very small programs. This pattern is commonly used in order systems, vending machines, ATMs, traffic lights, and games. In conclusion, this demo showed how the state design pattern can organize behavior that changes based on an object's current state. In my project, package order delegates actions to the current state instead of using many if else statements. Each state class controls what actions are valid and what state comes next. This makes the code cleaner, easier to understand, and easier to extend in the future. Thank you for listening. This was the end of the presentation for my demo.